Greetings, students. Today we're going to discuss practice test 3-5. Let's begin. Question 1. Diagonal multiplication. I'm going to multiply 4 by v. That's going to yield 4v. Then we'll multiply 2 by v and 2 by 10. That's going to yield 2v plus 20. Step 2. I'm going to subtract 2v from 4v. That's going to yield 2v. Step 3. We're going to divide 2 into 20 and get v equals 10. It is possible to check your work here. 2 out of 10, which is 1/5, is equivalent to 4 out of 20, 1/5. Question 2. There are a couple ways to approach this question. Because the multiple is integer, 3 is tripled to become 9. We can divide 18 by 3 and set -6 plus 2x equal to 6. However, if the multiple is an integer, you will have to set this up with a ratio, which is what I'm going to do. So I'm going to put the smaller triangle in the numerator. So -6 plus 2x equals 3. Now these aren't equal, but they're both on the same triangle, so they're related. And the 3 goes with 9, and the -6 plus 2x goes with 18. Now again, there's other ways to set up the ratio, and the key here is consistency. I put the smaller triangle on the numerator and the bigger one in the denominator. As long as you're consistent, there are multiple ways to set this up. The items that need to be diagonal are the 18 with the 3 and the 9 with the -6 plus 2x. As long as it's diagonal like that, you're good to go. So here I'll reduce 9 into 18 because it divides evenly once, so that becomes a 1, and that becomes a 2. And then like I was saying before, 2 times 3 here is 6, so -6 plus 2x is equal to 6, just like I was saying before. Adding 6 to 6 yields 12, and dividing 12 by 6 yields 6. Again, if this isn't an integer multiple here, 3 triples to become 9, you will have to set up the proportion like this. If it is an integer multiple, feel free to divide 18 by 3 and just set this -6 plus 2x equals 6. Alright, question 3. I don't have the bottom with the 28 here, so the 28 here is completely useless. So just forget the 28's there. It just as well not be there, because it's completely, utterly useless on the question right here, unless I was asking you to solve for that side, which I'm asking for the scale factor. So either set the 12 with the 16, or the 9 with the 12, because those are the sides that relate together. And it's the same ratio either way. So 9 with 12, that's the same as 12 with 16. And then you're going to have to figure out what of these numbers it makes. So 9 with 12, those can divide by 3 and become 3/4. 12 with 16 can divide by 4 and become 3/4. So they both make 3/4, a 3 to 4 ratio. Question 4. I'm looking for this, and it goes with the 63 on the same triangle because they're both on the big triangle, or with the 108. Now, because I've labeled all 3 sides on the other triangle as well, you can use any of these 3 sides here. So you have to use the question mark on one of them, of course. So x, I can either use the 63 or the 108, and again, it's just dependent on how I want to do the question. So I'll use the 63. And now once I've set up that triangle, the big triangle, the smaller triangle, this question mark goes with the 36, so this needs to be 36 now. And this 63 goes with the 28, so that needs to be 28. I'm not using the 48 here because I didn't use the 108. Anyways, so here again I'm going to cross multiply. It is possible again to reduce vertically or horizontally before I do my cross multiplication, and if I am doing this by hand, I would reduce it before I did my cross multiplication. So I would take 63 times 36, 2268. And then divide that by 28, 81. If I am having you do this by hand, again, you're going to have to divide this. Well, you'd probably choose 4 here, because 4 goes into 28, and it goes into 36 evenly. So 4 times 7 is 28. And 4 times 9 is 36, so this should become a 7 and a 9. And then 7 goes into 63 9 times. So I would divide 7 and 63 9 times, change that into a 9, and I get it 9 times 9 is 81 in terms of the reduction by hand. Alright, question 3. Question 5. Solve for x, the triangle and each pair are similar. So again, you're looking at this, it says UV goes with US. UV with US. So I'm going to take 2x minus 6. It's supposed to go with US, not with UT, with US. So 2x minus 6 with US. 6, not 12. 6. And again, when I set these up, I like to put one triangle on the top and one triangle on the bottom. So the 2x minus 6 is on the same triangle with the 28. And the 12 is on the same triangle with the 6 here. So I'll put the 12 here. And again, it is possible to reduce horizontally or vertically. So 6 and the 12, well, that's a nice even integer right there. So why don't I just change that into a 1 and a 2? That way I can just make 2x minus 6 equal to 14. So I don't have to do a whole bunch of extra effort here. 6 and 14 is 20. Therefore, x is 10. Now, again, it is possible to check your work. And this one happens to have a nice integer scale factor, 6 and 12. And then I have 6 and 28 here. And then here I've got 28 and, well, 20 minus 6. 20 minus 6 would be 14. And 14 and 6. So again, the ratio here, 12 with 28. If I divide that by, well, what would you divide by? Divide by 4, right? 7 thirds. And then 14 and 6, 7 thirds. It just so happens that their scale factor actually works this way as well. 28 and 14 is 2. 12 and 6 is also 2. Anyways, 10 is a geometric mean of 5 and what number? So again, when I'm doing this, I'm going to take, well, either I'm going to do 10 squared, 5 times x equals 10 squared. Because remember, when you're doing geometric mean, you're taking the square root of two numbers multiplied. So 5 times x, square root of 5 times x equals 10. So therefore, 5 times x equals 10 squared. So that would mean x is 25. The other number is 25. You're either doing it that way. I said 25 there, didn't I? 10 squared is 100, but when you divide 100 by 5, you don't get 25. When you divide it by 4, you get 25. You get 20. You divide 100 by 5. I meant to say 20. You can either do it that way, or you can approach it with the pattern method, because it's a nice pattern here. You would say, well, if the starting number is 5, to get to 10, I'd have to double it. And I'm going to have to double 10 again to get to the other number, 20. Again, it's a multiplicative mean, so in other words, 10 is midway between 5 and 20, multiplicatively. Alright, next one is a triangle, right triangle. I'm going to ask myself, is 9 squared, the two legs, which are 9 and 12, is 9 squared plus 12 squared? I'm putting a question mark here with the equal because I don't know if it's equal yet. I'm asking if it's equal. Is this equal to 15 squared? So 81 plus 144. Well, 15 by 15 is 225. I told you you needed to know that one. You should know that one by now. Well, 81 and 144. I'm just going to take my time here. And 81 and 144, I'm going to think about it. Yeah, that is 225. 225 does, in fact, equal 225. So the answer is yes. Now, again, I'm not giving you credit for this question unless I see this. Work. I need to see that you've actually figured out that it's equal, or that it's not equal. Don't just guess here and think you're going to get points. You're going to get 0 points if you just guess on this question. Alright, next one. Find the missing length indicated. So this length x is on the smaller triangle on the left and on the smaller triangle on the right. So on the left-hand triangle, it's the short side. And on the right-hand triangle, it's the longer side. So I'm going to start with the right-hand triangle, x and 9. So this is on the left-hand triangle, x and 9. Now on the right-hand triangle, I need this length here of 16. That entire length of 25 is useful for the big triangle, the entire triangle, the whole thing, but not for the left-hand triangle. So now the proper setup here. Again, it should go the short side with the short side, long side with the long side. So x is the longer side on the small triangle. And on the big triangle, it's the shorter side. So this x needs to be here with the 16 here for this to be set up properly. So x squared is equal to 90 plus 56, 144. Therefore, x is equal to 12. Again, I'm not using the negative root here. X would be positive and negative 12 if I were to do this algebraically. However, since it's a picture, and that length is never negative, I'm only using the positive 12. When we talk about this again next year, x can be negative when you have x squared equal 144. When we talk about it again next year, if it doesn't have a picture, a length with it, in other words. Anyways, so there are 18 questions this week on the test. So it kind of makes sense to assign, what does it make sense to assign here? 6 or 5 points per question. So most of these on the front I'm going to make worth 6. That way there's going to be 48 points on the front. I'll make these worth 6 on the front. And then on the back I'll make some of them worth 5. So that we can end up adding up to 50 total. Anyway, so 48 points on the front is what I intend to do. And always out of 100. Alright, next page. Page 2. Or second half. Put a piece of tape down here so it's easier. Get it nice and set up. There we go. State if the triangles are similar. So I'm asking if the ratio is the same between the lengths. So again, I'm looking at this one. 28 with 36. That's on the small triangle. It's 28. Should be going with the 36. Now I've got two options here. Either I can subtract the 28 and the 77 to get this number here, or I can add the 36 and the 63 to get this entire length here, and it's entirely feasible to do it either way. So either I'm going to do a 77 with a 99, because 36 and 63 is 99, or I'm going to do 63, and then 28 from 77 would be 49. Take your pick. It's entirely possible to do it either way. 77, 99. So is this in fact the same number? So again, I can reduce horizontally or vertically. It should be appropriate either way. Let's reduce horizontally only though here just to be safe. That's what it's called. So 7 goes into both of these. 7 goes into 28 4 times. And into 77 11 times. So it's looking like that ratio 7 to 11. 7, 4 to 11. And then 66 and 99, I'm thinking that's dividing by 6 into both of those. Because 6 by 6 is 36, and then 99 divided by 6 would be 11. So in fact, these triangles are not similar. Not similar. Because the ratio between the lengths is not the same on the two triangles. And again, I related the smaller sides with the longer sides. The smaller triangle with the bigger triangle in terms of vertical relationship here to get this properly set up. Question 10. Pythagorean theorem. So a 9 and a 12, we just had that on the last page. 9 squared plus 12 squared, we just did this. Equals x squared. That's 81 and 144. That is 225. And again, because I'm only looking for the positive root, I'm just going to put my positive answer. X is 15. Since it's a length, X can't be negative. Alright, next question. Find the missing lengths. This is from our unit triangles. The 30, 60, 90 and the 45, 45, 90. So again, the 30, 60, 90, the hypotenuse, should be twice the length of the short side. So whatever this length here is, if it's labeled as a hypotenuse, I will divide it in half to get the short length. Or if I give you the short length, you'll double it to get the hypotenuse's length. So the length of y is equal to 20 divided in half, which is 10. Once I find the short length, I can multiply by the square root of 3 to get the other leg, the medium length on this triangle. So the medium length x is 10 square root of 3. This is not a calculator question. This is a ratio question. The ratio on the sides of the 30, 60, 90 triangle are 1, 2, square root of 3. In other words, 1 is the base length. This is your base length. We double it to get the hypotenuse, and we times it by the square root of 3 to get the other length, the other leg here. And it works backwards as well. If I give you the hypotenuse, you divide it by 2 to get the short length. If I give you the longer leg, you divide it by the square root of 3 to get the short length. The other right triangle, the other unit right triangle, is the 45, 45, 90. The isosceles right triangle, keyword isosceles. So these two angles are the same, meaning that these two sides will be the same. So n must be 3 here. And then to get to m, you can do the Pythagorean theorem. 3 squared plus 3 squared is 9 plus 9, which is the square root of 18, which reduces into 3 root 2. Or you can just remember the ratio is root 2 times by the root 2, because that's the ratio on the 45, 45, 90 triangle, or the isosceles right triangle. And the ratio is 1, 1, and then root 2 times by root 2. So in other words, whatever these legs are, we can times either leg by the square root of 2 to get this hypotenuse, the longest side. Alright, next one. Sine, cosine, and tangent, SOHCAHTOA. Trigonometric ratios. So sine is opposite over hypotenuse, S-O-H, opposite hypotenuse. So this will be the opposite side from the angle over the hypotenuse. The hypotenuse is the longest side on the right triangle, so you always identify the hypotenuse first. So on this particular triangle, number 13, the hypotenuse is the 30, because it's the longest side. It's longer than 24 and 18. The hypotenuse is the 30. So in other words, this ratio here is going to be over 30. And then from that, you can identify your opposite side, in this case, because I want the SOHCAHTOA. I want of the SOHCAHTOA. So the opposite side from A, the side opposite is the side across, or not touching A. The side that does not touch A, in other words. This is the opposite side because it does not touch A. 18 is touching A, is connected to A. 18 is the adjacent side on this particular triangle to angle A. So the trigonometric ratio here is 24 over 30, which does reduce divided by 4. The reduction here is secondary to the question. So it does reduce divided by 4 and becomes a 4/5. But that's secondary to the actual question of the trigonometric ratio. Next one, cosine. I want the ca here. C-A-H. Adjacent hypotenuse. So this is adjacent hypotenuse. So again, we identify the hypotenuse first, the longest side of the right triangle. That's the hypotenuse. And then in this case, I want the ca, the adjacent side. So adjacent to A is the side that connects to A. 30 connects to A. And again, 30 is adjacent because it's not the hypotenuse. 50 I know connects to A as well. Yes, 50 connects to A, but it is the hypotenuse. It's the longest. Always identify the hypotenuse first, and then from there identify your adjacent and opposite sides. So this will be 30 over 50, which again divides by 10. This will be 3/5. Alright, next one, tangent, TOA. So here I want the opposite and adjacent. Opposite, adjacent. Again, I always identify the hypotenuse first. Before I identify opposite and adjacent, even if I'm not looking for the hypotenuse, I identify it. 30 is the hypotenuse once again. So I'm not going to use the 30 here. So I'm looking at angle C. Opposite from C is 24 because it does not connect to C, and adjacent is 18 because it does connect. 24 to 18. Dividing this by 6 will yield 4/3. Tangent's the only ratio that can be greater than 1. Sine and cosine have to be between 0 and 1. So one thing you can do to look at your work here is the sine and cosine will always be between 0 and 1 in terms of their numerical value. And the tangent can be any number. It can be greater than 1, or it can be fractional, between 0 and 1 as well. Tangent will not be negative in our classes, however, because the triangles, the way we set them up, are not going to be in quadrant 2 or 3 or 4. Excuse me, quadrant 2 and 4. So tangent will not be negative. None of these will be negative, in fact, in our classes. All right, moving along. Solve the right triangle. So side A is the side across from A. A is 5. Side B is the side across from B. Well, it's not labeled, so we'll come back to it in a minute. Side C is the side across from C, which is 4 in this case. Angle A is unlabeled in this case, so we'll come back to it in a minute. But angle B is labeled with 90 degrees here. So there's half the points, because of the way the question was labeled. Now, to get the missing side here, side B, you're going to use the Pythagorean theorem. So 4 squared plus 5 squared will equal B squared. So that is 16 and 25. 16 plus 25, which is the square root of 41. I'm not looking for the reduction of the root here particularly. If it does reduce, I might assign a point or two to it. But I'm not really looking for the reduction of the root. All right, next thing, measurement of angle A and the measurement of angle C. I'm looking for just the trig ratio setup. I'm looking for just the trig ratio setup. So in other words, to find angle A and angle C, you would use a tangent setup because it's opposite and adjacent side from side A and from angle A and angle C. We have the side opposite and the side adjacent labeled. So the tangent of A here should be equal to 5/4, and the tangent of C should be equal to 4/5. So this will be the inverse tangent of 5/4. And this will be the inverse tangent of 4/5. Now, if I'm letting you use a calculator, you would type it in a calculator, of course, to give an angle measurement out. And because these are equivalent size, approximately equivalent size, 4 and 5, you would expect the numbers to be somewhat similar. So if I were to type this in a calculator, which I may or may not have you do on the test, 39 degrees, you would round to the nearest degree, and 51 degrees. And again, they add up to 90, so that makes sense, 39 and 51, with this one being the larger angle, because it's across from the longer side. Alright, next one here. The area of the polygon. Find the area of each regular polygon around your answer to the nearest tenth if necessary. So this is dealing with our concept of right triangles within the polygons. So in other words, an octagon here, 1, 2, 3, 4, 5, 6, 7, 8, has 16 right triangles within it, or you could think of it as 8 equilateral triangles within it. Equilateral. I meant to say isosceles triangles within it. I said equilateral, sorry. So the area of one triangle on this octagon, this triangle here in purple, is 10.7 times 12.9 divided by 2, and there's 8 of them. And I could draw them in here. I'll draw them in blue. So there's a second one, there's a third one. So 1, 2, 3, and these are all isosceles. They're not equilateral, but they're isosceles. There's the next one, there's the next one, there's the next one. So 1, 2, 3, 4, 5, 6, 7. There's 8 of these. There's 8 of these isosceles right triangles. And they all have an area of half of 10.7 times 12.9. So I'm going to take half of 10.7 times it by 12.9. That's going to be 69. That's about 69. And then there's 8 of those. And I'm using the calculator here to do this. So I will, I guess, provide calculators on the test for this material. 552 square units. I'm going to just play on 552. Would be the area of this regular octagon. 8 isosceles triangles within this regular octagon. And to get the area of one isosceles triangle, to get the area of one isosceles triangle within there, you do half the base times the height. Half of 10.1, half of 10 times by 12.9. And I don't think I used 10.7 there when I multiplied that. I should have used 10.7. So let's retype it in the calculator. 1/2 times 10.7 times by 12.9. I should have used 10.7 here. So that was actually, that is 69. I did use 10.7. I just didn't write it down here. And then I times that by 8. 552.12 or 552 square units. It says round your answer to the nearest tenth. So that would be 552.1. But I usually don't take off for rounding here. Alright, next one. I don't have the height labeled here. I have the apothem label. 9.2 apothem. So that is an issue. But we're going to approach it the same way we approached the last one. So I do have isosceles triangles here. So here's the first one. And then the second and third one are the same size. So again, I can approach this the same way as the last one. It would be nice if I would have labeled instead of the apothem the entire length here, or the entire height of the triangle, but I didn't. So I'll do half of 31.8 times by 9.2 to get the area of one of the triangles here. So half times 31 and 8 tenths times 9 and 2 tenths. Well, that is 146.28 or 146 and 28 hundredths. And then I can multiply that by 3 because there's 3 of those in there. They're all isosceles triangles in there. 146 and 28 hundredths times them by 3 will yield the area here. 438 and 84 hundredths. Approximately 438. I'll round it to the 10th like I asked you to. 0.8 square units. Alright, so there is a formulaic approach to these, but in general, what you want to do, what you can always do is make them into isosceles triangles with the height. And once you have the height of the isosceles triangle, just figure out how many are in the shape. So the hexagon would have 6, the triangle has 3, the pentagon would have 5, the regular pentagon, regular hexagon, regular octagon, the nonagon would have 9, and so on and so forth. Equivalent equilateral triangles. Anyways, I hope this helps. Come by Thursday if you want to ask some questions. I'll be here for a while after school. Bye.